All right, let's finish this homework assignment here. So, problem number 2 says in a recent survey of students at State U, it was found that 68% use Snapchat on a daily basis. 52% use Facebook on a daily basis, and 38% used both. All right, so let's just write this information down. We want Snapchats, that equals 0.68. 68%. Facebook, that's 0.52. And their intersection, Snapchat intersect, I guess we can just do probability of Snapchat, probability of Facebook, and probability of their intersection. Snapchat intersect Facebook is 0.38. That is what's the given information from the problem. 68% Snapchat, 52% Facebook, 38% their intersection. All right, part A, the probability a randomly selected individual uses Snapchat but not Facebook. Well, I drew a Venn diagram. So our Venn diagram will look something like this. Our intersection we do first. So Snapchat, Facebook. The intersection is this part in the middle there, and that is 0.38. And we know all of Snapchat is 68, so this area here is 0.68 minus 0.38, which is 0.30. And this, we'll do this in a different color-ish. So this is, Facebook is 0.52 minus 0.38, which comes out to 0.14. So now we just want the probability of Snapchat but not Facebook. Well, that's just 0.3, and that's given right here. All right, that's doesn't have any Facebook bubble around it. We're good. Similarly, Facebook but not Snapchat is it's 0.14. That's given in the solo other bubble, which is right here. All right, so now some of the more difficult problems anyway. Part C, the probability a randomly selected individual uses exactly one of the apps. Well, that's actually just these top two added together. Exactly one means exactly just Facebook or just Snapchat. So that's the two from above. So that's 0.3 plus 0.14, and that's 0.44. All right, D, the probability a randomly selected individual uses Snapchat given, let's highlight that, given he or she uses Facebook. So the known information is that person uses Facebook. So we're going to use our notation for this. So we want the probability that they use Snapchat given that they know Facebook, or use Facebook, excuse me. Well, our formula is the probability that the intersection occurs. So Snapchat intersect Facebook divided by the probability of the given, which is just Facebook. And we know that the intersection is 0.38, and Facebook alone is 0.52, and that comes out to 0.73. E, probably a randomly selected Snapchat user. So let's highlight that. We know that the person uses Snapchat. We want the probability that they also use Facebook. So this one becomes probability of Facebook given that they use Snapchat. This is the same intersection. You can write the intersection, Facebook intersect SC. It's the same as SC intersect Facebook. And that's over probability of Snapchat this time. So that same 0.38 over Snapchat is 0.68. And that comes out to 0.559. And the last one, probably a randomly selected individual. So this is the whole thing. Uses neither app. Oh, never mind. Neither app. Given he or she does not use Facebook. So it says the word given. So given not Facebook. Well, remember, probability that they use Facebook plus the probability that they do not use Facebook, Facebook will say complement, that has to equal 1. Okay? So that means that the probability that they did not use Facebook is equal to 1 minus the probability that they did use Facebook, which is 1 minus 0.52, which is 0.48. So we have that information here. Let's scroll down a little bit to give ourselves a little bit more room. Okay, so what we want is ultimately we want the probability of neither, given that they don't use Facebook. So Facebook complement. Well, that's the intersection of these. Neither, wrong symbol. Neither intersect not Facebook over probability of not Facebook. Well, we need to figure out what this area here is. Well, everything within the box that includes the bubbles must add up to 1. So let's use another color here. Try green. So this question mark. Probability of the outside, or we can simply say 1 minus the union. Let's do that. Probability of Snapchat union Facebook, I think all complement, is equal 1 minus probability of their union. That's what gives us our outside. 1 minus these other numbers, so 0.3 plus 0.38 plus 0.14, which comes out to 0.18. And that's 0.18. So ultimately, let me go back to the red here. Their intersection is 0.18, and Facebook complement was 0.48, and that comes out to 0.375. That's how we do number 2. All right, let's deal with number 3. This one should be a little bit more straightforward. It's not, in general, it's not a big word problem like some of these other ones were, where a lot of what you had to do was to be able to read and then pull the terms and the different things that you had learned out of them. All right, so we're given x values and probabilities. So let's go with 0, 1, 2, 3, and 4. These are my x values. My probabilities are over here. They go up to 0.35, so I'm just going to go every 10th. Be careful not to, my 0.1 and 0.2 are a little bit bigger off, but hopefully you can get an idea. You don't want to just put in those numbers, 0.07, 0.13, 0.14 on the left-hand side. That's not going to go well. You need to be able to show it to scale. All right, 0 goes to 0.07. Here, let me do it with this. 0 goes to 0.07. So maybe here, a little bit under the 0.1. Then we've got a 0.13 for 1. 0.14, just slightly above maybe for 2. 3 is 0.31. And pardon my widths being a little bit too much. This 0, 1 should probably go over more. And this one's 0.35, so a little bit more here. So something like that. And That's how we draw the histogram. Make sure that you label each side. A balancing point. A balancing point, think of a teeter-totter. Like, where can we put a dot here that we can balance this graph? Well, maybe someplace here-ish. We know it's going to be above 2 because there's more stuff at the 3 and 4, and that's basically what we can say for B. So 2 is the middle value. But there's more stuff. More data above 2 than below it. Something like that. And now we want the expected number of siblings. So we're going to use the 1var stats, and I'll show you how you do that. So let's see here. Turn our calculator on. Now we need to enter these values in a list. So stats and then edits. Let's clear a list. Go up, hit clear, then enter. Clear and enter. Now we just need to enter the values. So 0, 1, 2, 3, and 4 are my x values. 0.07 and so forth. So I've got the x values in list 1 and the probabilities in list 2. And we do 1var stats. So second vars, stat calculate. We need the 1var stats, but we need to tell it both lists. So we're going to use the second key and the 1 for list 1, the commas right above the 7, and then the second list and 2 for list 2. If you just use list 1, your answer is going to be as if you had 5 pieces of data, 0, 1, 2, 3, and 4. That's not what you want. This is a weighted distribution here. So the mean, even though we don't actually have mu, it's actually considered mu, that's at 2.74 at the top. And that's the units or label is siblings. If we wanted the standard deviation, that's 1.254-ish. That wasn't asked. Also, please note there is no S of x because it's not a sample. This is a distribution, so we're using the population standard deviation for that.